All right, word problems. Had to happen eventually. The area of a rectangular sheet of paper is 300 centimeters squared. Here is a piece of paper. It has a length which is 5 more than its width. So I don't have a clue about the width, but the length is 5 more than that. Form a polynomial equation and solve it to determine the perimeter of the sheet. Well, if the area is 300, that means length times width is the area. Someone did x times x plus 5, and they found that that was 300. If we expand this left-hand side, we get x squared plus 5x, and I'm actually going to hop this 300 back over to the left-hand side. There we go. Now it's a quadratic. It equals 0. Now we need to factor it. So we need two numbers which add up to 5 and multiply to minus 300. This will be interesting. How many ways are there to make 300? Regrettably, there are quite a few. 3 goes into 300. 4 goes into 300. I'm watching for a couple of numbers that differ by 5. That's the big thing. These are not even close. Like with these two numbers, for example, you can make 79 or 71 depending how you adjust the signs. So nowhere close yet. 5 times 60 would work. 6 times 50 would work. 7 doesn't go into 300. 8 does not go into 300. Neither does 9. 10 goes in 30 times. 11, no. 12 goes in 25 times. 13 doesn't go. 14 doesn't go. 15 goes in 20 times. Hello. These numbers differ by 5. If we use x plus 20 and x minus 15, that should give us what we need here. So there it is factored. Now the zero product theorem says we can solve each of these independently. We can have one solution that's x plus 20 equals 0, or the other possibility is x minus 15 equals 0. So we solve each one of these. If x plus 20 equals 0, that means x equals negative 20. Or, take this 15 to the right-hand side, and we get x might be positive 15. Now, quadratics, we're used to getting two solutions, but in this case you have to stop and think, are both of these solutions valid? This is telling us that we have a rectangle which is minus 20 on this side and minus 15 on this side. Well, negative lengths, not good, generally not allowed in geometry, so that doesn't sound like a valid solution to me. If you run it the other way, though, if x is 15, then we have 15 centimeters this way by 20 this way, which does make perfect sense. Notice the other solution was also 15 and 20. It just happened that both numbers were negative. The math offered us both. It said, well, minus 15 by minus 20 satisfies all the conditions you gave me, and so does 15 by 20. This equation doesn't know that the negative isn't valid, so it gives you both versions, and it's on us to realize that, well, this one works and this other one does not. Sometimes a negative solution can be valid, but in real-life questions that are about how big is a piece of paper or how many cookies does each kid get, quite often the number with the negatives in it is not going to make physical sense. So, 15 by 20 sheet of paper. Now, watch out. We aren't entirely done. They didn't want the sheet's measurements, they wanted its perimeter, so the distance all the way around its outside edges. This thing is 15 by 20 by 15 by 20, so its perimeter is going to be the sum of all its outside edges, like that. 15 and 15 is 30, 20 and 20 is 40, 30 plus 40 makes a total of 70 centimeters. Yay, we win.